Hey everyone, hope you're doing well. Today I wanted to make a video that went over factors and, well, as the title suggests, some other R tidbits. So I didn't introduce factors as a class of data type when we first were talking about different types of data like character, logical, numeric, etc. And the reason for this is because factors are more of a historical variable, and they're a little bit confusing, and I didn't want to throw people off. But they're really important in R because to kind of understand that historical sense. So you probably encountered them already. For homework 2, you had to use factors to sort of reorder a character vector to be able to plot it in a particular order. But I wanted to go over it in a couple different details and kind of let you know how to manipulate factors and work with them, and some also go over some historical stuff just because it gets in the way sometimes, more so than anything. But then when I was making it, I also realized that I could give you some other R tidbits. For example, you can actually send, so you notice what I did, I deleted the right parentheses, and so if I hit Control Enter here, you can see that I can still send it to the console, but what I ended up getting is these plus symbols, and it doesn't actually print out the sum of 1 to 3, as you might expect, because it's missing that right parentheses. So you can, if you realize that you're just missing a parentheses, oops, I'm still typing up in the script pane, so if I go and I fit in the right pane, or the right parentheses, you'll see I'll actually get the number out. If I were to send this to the console again and get the plus plus, if you just didn't know what the error was, because if it was like a parentheses that was missing but you don't know, you have multiple functions or something like that, you can just hit escape and you'll get out of it. And you notice that I'm still now on the little greater than sign, so I can start typing normal code again. Of course, if you just run like a code chunk where there's that kind of issue, you'll see that there's an unexpected error because it's this plus sum doesn't get evaluated because it's trying to put this sum function in this one, and it gets confused. So again, just a little note. Also, you can see that RStudio got really mad at me for leaving on an unmatched left parentheses. So hopefully that you'll not make that mistake. But I have done similar things, and it can be frustrating just how you get this off the console. So first tidbit there. But let's cover factors. So I'm just going to read off of what this says. Factors are variables in R which take a limited number of different values, such as variables often referred to as categorical variables. So a good example of this is sex, male or female, or time, days of a week, maybe something like quarter 1, quarter 2, quarter 3, quarter 4, and if there's of different years, if it's a financial report. And factors, so what makes them different from characters is that typically they're either just limited or that they have an order, and so we'll get to that. But historically, factors are used because they are a very efficient way to store character values, because each unique character value is stored only once, and the data itself is stored as a vector of integers. So that's to say, if you had a data set that was 1,000 rows long, and you had a column that was sex, and it was taking on two values, male and female, instead of having to store the character male or the character female, which is obviously 4 to 6 characters, you can just store a 1 there and then kind of have R in the back end know that 1 is equal to male, 2 is equal to female. And so the reason it was done like this, obviously, is because before, computers didn't have a lot of RAM. So imagine if that's just 1,000, but let's say you had 10,000 or more variables. You can see how saving those couple of characters might actually add up at the end. So it is a historical thing, and we'll get into that a little bit more later. But the other thing that they are useful for is reordering things, like I mentioned for those graphs. So I mentioned it's good for dates and time and things like that. So let's go with and talk about months and by month name. And so, by the way, for certain things like letters, for example, I believe R stores letters as letters, and you can see there's two types. There's constants built into R. Letters are just A, B, C, D, all lowercase. Letters, capital, are obviously the caps of those letters. So kind of a nice way that if you didn't want to type in A, B, C, if if you were going to just order them in that way, that they're probably already stored that way. Similar with month name. Month name, if I print it out for you, you can see what's printing down here. January, February, March, April, May, June, July, And if I look at the class of month name, you'll see that it's a character class, though. So there's not an order that's prescribed to them. It's in this particular order, like the first index of month.name. So month.name is a character vector. The first indice is January, the second is February, but we'll see how that can be problematic. So I already have some code written here, so I wouldn't forget it, but basically I'm just going to make a vector of months, and I'm going to repeat month name 10 times. So what this will do is this function rep will repeat January 10 times, and then I'll go to February, repeat that 10 times. And so if I run that, you can kind of see that over here. Actually, it repeats, sorry, I got that wrong. It repeats the vector January, February, March, blah, 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 and then it goes and repeats that again 10 times. So you get the months written 10 times. The reason I'm doing that is because I'm actually going to sample that 120 months. Sample creates a random sample, so it's going to sample months, it's going to do 36 times, and it's going to replace the values. That is to say, if it takes out a January, it will replace that January, so it's equally likely to pick that same January again. So if I do that, I get a list of character, or a character vector of 36, length of 36 with random months. The reason I'm doing this is just to create some randomness here. And you can see now that the order that they're printed off is January, October, October, June, October, etc. The point being that, they're no longer listed in a particular order, and there's no real order prescribed to them. So this might be how you find data in a data frame, right? You might just be like, the date so that something was issued, and the first entry happens to be January, but then the second one happens to be October, June, etc. And if you were to sort, sort is a function that sorts the data. It defaults to sort it in alphabetical order. So if you see what's happening here, all the Aprils are coming first, then Augustus, and then, so on. Another thing that you can do is also table, and I'll explain table a little bit more, but what it does is it counts each value for you, and so it puts a nice little thing. Instead of showing, all of them, you can see, it sampled November 6 times, or October 8 times, which maybe makes sense based on what I was reading there, and it only sampled September once. So. But you can see the order that it puts it in. Again, April, August, December. It's going in alphabetical order. That is sort of the default way that R tends to implement factoring, because table actually does puts things into factors and then counts them. So if I wanted to convert, let's say this example months and everything, if I wanted to convert that to a factor, so it actually, when I do sort and I do table, it lists in the correct order, what you can do then, the function you want is factor. Factor, the first argument to the factor function is x, which is just the vector that you're trying to sort. So I'm going to sort this vector character example months is the one I'm going to make into a factor. And then the main one you want to be able to do is levels. And levels is going to be, well, I actually have the months in a particular order by the month.name. So month.name again is a vector where it says the months in the order that I would like them to be in. So January, February, March, April, again, from when we printed that off before. So if I run this, now I have this a factor. If I print it off, let's do that. Oops, Control Enter so I can print it off. You can see that it is still listing them in the order it appears, because it is still that October is in the second, position, But you can see that it also prints this off. It has 12 levels, and the levels go January, February, March, April, May, June, July, etc. Or it has that information stored there. So now if I go and sort this factor, you see that it's actually sorting it, and it's going to put it in all 36 sample vector indices. It's going to put them in the order that I wanted them to be in, January, February, etc. And of course, if I do table of this, it's going to give you the same data. It's going to give you the same numbers that appear with them, but it's going to actually list them 3. And you notice actually that February got 0. So you can assign, and so this is kind of interesting that with the samples, February sampled 0 times. If we did this, you see that it was 0. But if you were to do this table of the character, you don't see February listed at all. It doesn't appear there. The reason for this is because when we set the levels actually did contain February. So it knows that there's supposed to be 12 values there because of setting that levels there. Unlike when it was doing this. The other thing you can do, which is, so, right, I mentioned that having a factor already puts it in a particular order, but you can actually order them, and there's a couple of different things that are beneficial. The order maybe makes sense if you had like ordinal things, like a first, second, third kind of information, because you can do operations like less than or equal to, or you can always do equal to because characters, but you can do less than or greater than, for example. So the argument you just do is ordered is equal to true. And it's not going to make any sense, but let's do FCT example months, and let's do 1 to 2 just to show you what those are. So it's going to be January and October, right? And it shows you the levels also. It shows you that because again it's a factor, so it's going to print out all of the levels, and it says January is less than February is less than March. So if I did this and I take the first level or the first thing, which is January, and I say if it's less than the second one, which is October, you'll see that it should be true because January, as we saw when it was printed off this whole thing, you see that January was less than, eventually October would be somewhere in this ... right? So again, it's not actually probably that useful if you're going to use it for dates or something like that, but it can be useful in certain instances where you can do sort of logical questions about it because there is an order that's given. Like I said, if you have like first, second, or third. So second R tidbit is I want to talk about the table function. The table function is actually really useful to just get a sense of the data. I know that I mentioned before that often you use data visualizations to get a sense of the data, or some people, you could just view the data by clicking the little view button. But so we created a survey that is really stupid. I just made up all of the responses in here. And so basically there's a survey where it was yes or no, and you can see the survey responses. It was randomly sampled between no and yes, and you have a number from 1 to like the number that it came in. There was 200, so it just goes from 1 to 200. So table is a really nice way to say, like, well, if you look at this data, you can see like, well, I don't actually know if there's more no's or yeses, and I can't really get a sense of that right now. Of course, I could just do other things to get a sense of that. I can just sum which values are equal to no or things like that. But if I wanted to get both values, yes and no, table is a really good way. So what table will do, even though it says it's a character value here, it actually figures out the factor levels. So it says no is one factor, yes is another, and then it counts the number, because those are the only two that exist. It'll just count those and kind of display it in a little table thing here. So nice, and actually it was a random sample, but it ended up being that no happened 100 times and yes also happened 100 times. So real 50-50 split between no's and yeses in that survey. But what the table is not very good for is if you were to use, if it doesn't really fall into categories, if it's going to be numeric values that go kind of randomly, especially if they have decimal points or something like that, please never use table, because so here I'm running table, the survey, the number from before. Again, that runs 1 to 200, and because my computer is really slow at printing things out to the console, I'm only going to run 1 through 63. So basically it's just the first 63 values, and you can see that this is what happens when you do that. Every value is appearing once, and while maybe that's useful to know, there's easier ways if you want to know if things are unique across a thing. There's a function, unique, where you can check those type of things out. But that's why, so table is pretty useful when you have a couple of values that categorical values, and you're looking to get that summary. So hopefully you can find it useful when you're going through data and kind of trying to check out the structure that it has and everything. All right, so now I'm going to go back to talking about a little bit more focused on factors and stuff, and kind of also going through an example of loading data into base R and doing a plot and coming across some sort of messy data. And I mentioned in the homework post that tidying data or data wrangling and kind of that formatting of data is the sort of thing that takes the most time. It's like 80% of the work, and that's kind of where the annoying frustrations come in with coding, because you needed to be in a particular format to be able to work often, and often the data that you have is not going to be in that format because life can't be simple. So I made this CSV document in Excel, so it doesn't really make anything. This first thing is that the column name, for whatever reason, when I'm using the read.csv, for whatever reason it doesn't work very well. So I'm just replacing it with what it should be, place. So, well, let me just click on here, view base R. It's the same exact thing. Maybe because I was doing this in a code chunk. Oh, view is capitalized. Oh, I didn't know that. Okay. Anyway, so there's another R tidbit for you. So here's how base R looks. It's just the place that they came in, so I have something that is going to be obviously a factor, probably first, second, third, fourth, fifth, and the earnings for that, and just some names and stuff like that. And then because I wanted to just let you know that there's other things about the data, about changing values into like logical values, and I put this here. This is also, if you kind of hover over it, you can see that there's going to be character because the first one is quotes, but the rest of them are actually look quite like logical values. But again, if there's going to be two, it's going to default to character always. So let's go back and start playing with the data, and you can see that it's not really in a great format. So here, let's update this by just printing it out. But let's go and plot. So we have earnings and place, and that's what I'm going to plot against each other. So I'm going to make a bar plot, but in ggplot, if you don't know that already, it's going to be a column plot, because in columns you specify both the x and the y, and bar actually just counts data. So the data here is going to be this base R example, and I can also do set this at x, where x is going to be the place that people finished, and y is going to be equal to the earnings that they get, hit the plus, and geom call I almost said geom bar, and I don't think I need to specify anything else. Oh, I forgot to run library ggplot. So run library ggplot and wait a little bit because my computer's slow. I'm also apologize if this video is in any way sort of messed up. You know, this is my third setup for making videos, so because of third computer. So you can see what happens here, and the view is not great because I've zoomed in here. But, well, first you look at the place and you see it's just ordered kind of randomly. What would look randomly, of course, it's just alphabetical order because, like I mentioned, it's going to try to make these characters into factors. I actually read a post from Hadley Wickham, who created ggplot, about whether or not to rechange these so that it just appears in the order, and he said no, you learn factors. It was basically his response. So that's one thing. But then if you notice the numbers here, if you notice 1 million is the lowest value, and then it kind of goes randomly. So the idea behind this is actually that it's going by the first value. It's, again, reading characters. So the first value for all of these are $signs, so it's actually, you know, that doesn't help order anything, but then 1, 0, so okay, that's the, you know, the least value, and then 1, 3, then 1, 9, and you can see how it tried to interpret it. Again, so, you know, what just happened if you just look at the structure of R. Slow computer. Eventually it'll print out something that looks like this, and it says characters are first, second, third, fourth. Again, it's a character vector, and it's not ordered actually yet. And then also the earnings, because of the $sign and because of the commas, they are treated as character values, so not great. So let's just hit base R, and you can also see this if you were to print it out, right? Characters. I already mentioned it by if you hover over something in the view. So, all right. So we need to convert the strings to something else, and one thing you might have known is this as.dot function, and so you can do as.numeric, for example, and base R earnings. So it's going to take this column here and it's going to try to make it numeric, and it's not gonna work. Look, NA is introduced by coercion. NA. The reason why is because it doesn't. There's a $sign. It can't make that into a number, so it doesn't know what to do, and it makes it an NA. So the actual way to do this. So the first thing is I'm going to do just take the run these two, and I'm going to get a vector here. And the reason I'm doing this and printing it out is just so you see the values again. You can actually see that there's a space at the end too, which is something that if it was just a space at the end, you can do as numeric, and that would get rid of that space. And sometimes spaces at the beginning or at the end will mess up your data. So again, looking at it with str, or printing it out and making sure numbers are actually listed as numbers are helpful. But the first thing we want to do then is to remove the $sign and the comma with gsub. So if you haven't run into gsub already, and I believe we've talked about grep, and if we haven't, I apologize. Grep and grepl are super important, and in part of the same sort of family is sub and gsub. So I'm going to talk about gsub. Grep is used for finding values. It really should be probably its own video, and I'd highly recommend you looking into it. You'll probably come across it if you just Google some certain things about, like, how do I get only the values that have an R in the name of it, grep. If you want the logical version, grepl. Well, sub and gsub are similar. The difference between sub and gsub is sub only finds the first instance of the thing. So since we want to remove the $sign from all of the values here in earnings, we're going to use gsub because it's a global substitution. That's what the G stands for. So luckily our studio tells me what I'm supposed to do. So the first argument is pattern, and the pattern is going to be a $sign, and this isn't going to work. I'll give you a hint. already. Replacement is, well, in this case, you might be wondering, well, what are we going to replace it with? Well, we want to replace it with nothing, and you can replace it with nothing. But you have to say that you're replacing it with nothing still. So the replacement is quotes empty. Don't put a space there because it will replace it with a space. You have to just put quotes and nothing in between them. And the x is, as a lot of these sort of base functions are, is the vector that you're doing it in. So earnings was that one. I already mentioned that this isn't going to work, and you can see that it prints out here the dollar sign is still there. Why does the dollar sign still there? Well, in the quotes, and we'll get to this, and it's actually really useful, but the dollar sign means something to R, and so R still tries to interpret it, so you have to tell it that, no, I just want the character or dollar sign. Don't tell me, don't look at that dollar sign, actually. And so you want to escape that value, and escape just means, treat the value as the value. So often if you have like a dot, for example, if there was something where it was like 1.2, for example, in a data frame, and you wanted to remove the dot, you would still have to escape it with a dash or a backslash. So super helpful to know about that. So now if I try it, you can see it got rid of the dollar sign. Now, if I wanted to do the commas, you don't have to escape commas. It doesn't have any special meaning to R when it's in the quotes like that. So replacement is equal to, I'm not replacing it with anything, x is equal to earnings. And obviously if I wanted it to actually update without the dollar sign, now this will have the dollar sign but no commas. If I wanted to update it, I could do earnings is equal to, and then, or is assigned to this, and then I could, Is there a way to do both at the same time? Yes, there is. Okay. The other thing I wanted to mention, though, so I'm actually just going to go back to earnings and assign it to be base R, and to make it so that that's clear, I'll actually just get rid of these, so not do the assignment. Again, I'll print out earnings, and it's back to its ugly self. So if I wanted to, there's also these things called regular expressions that I kind of want to bring up. That's here. Regular expressions are how you can communicate with, in particular with strings, in most languages. So for example, there's if I wanted to sub any number, so let's try it actually. I did not plan on doing this. So the pattern is going to be, okay, like I said, I didn't plan on doing it, and I had to look it up because I forgot an extra set of brackets. So the regex for doing this would be to say because again, it's going to interpret this, there is some interpretation that's going on here, and so it's going to actually interpret this as any digit. It's going to replace that with 0 and earnings, so if I run that, I actually get that, those nothing, basically the dollar sign, the comma, and then the space that comes afterwards. So while that was interesting, the other thing I wanted to point out is there are ways to do like the first character. So the other way is, like, remember we were able to get rid of the dollar sign, but let's say that there was I wanted to just get rid of the first character. The first character is to do this symbol, the caret, and then the dot. So the dot is going to be anything that's there at the first instance of it. Replace it with 0, and again with earnings. And remember, earnings is something where it already has the dollar signs in front of it again. And you can see that we were able to replace that first character with nothing, so we were able to place the dollar sign that way. So, you can see that there's going to be multiple ways of doing things. Again, this is just how to talk about that there's this thing called regex, or regular expressions, that are super useful if you want to replace a certain thing. Again, I ended up having to just Google it about how you replace all digits because I forgot a bracket, but this is going to be potentially useful for getting things in the correct format, and also finding things. So you can, if you're using grep, you can use grep with a pattern is going to be, the first digit is the first thing is a dollar sign, for example, and you just get those values out. Or you could do a value that contains, a comma or contains a dollar sign. So let's actually update the base R earnings. And so how you do this in base R is actually, I have the column base R earnings, and I would like to assign it to be, a G sub, and I need to tell you how to do two symbols at once. And again, there's some interpretation here. So if you know the logical symbol for OR, that's what you would put here. And if you don't, it is actually shift and then the backslash key, the vertical line. And so I want, basically, what this is saying is that the pattern, let's erase the extra P there. Pattern is equal to dollar sign or comma, and I'm going to replace replacement is equal to nothing. You can't probably replace the dollar sign with something and the comma with something else. You'd have to actually run it twice then, but since we're replacing with the same thing, this will work. And X is going to be, just to make it clear, base R earnings. So I'm taking the original base R earnings and I'm replacing it with what this is going to be by assigning it this way. Now hit Control R and let's just print it out to see if it works, or I could just view it or something like that, but we'll do it this way. And you can see it printed here and there, that it works. But if we go back to base R, that actually solved this one, but it did not solve this problem of the real, for this first one being true. And so how you can do it again in base R is I want to take base R, and I want to take the real dot column, and I just want the first value. I just want to mess with the first value, and I know exactly what it should be. I want it to be true, the logical value, instead of in quotes. And you can actually run it this way, and not only it updates base R. So now if I look at it, you see that the value doesn't have a quotes around it anymore. So now it looks how it probably should. You have you have the values that are actually numeric and everything, and real as a column. But let's print it out, and it says it looks that way, but it still says character here. And the reason for this is because it was a character before. There's nothing that we told it to update the character. And there's two ways you can do that. The first way would be to kind of do the same thing that we're doing before. We want to replace the earnings column with as numeric version of this. And now it'll work because it sees only numbers. So, let me just print out as numeric, and you can see I have it commented here. The reason we're not actually doing it is because I mentioned there's two ways, and I kind of want to talk about the second way and also a problem that it introduces. So, I forgot the R in the name. So as numeric base R, and you can see that it works. It's printing out. It doesn't introduce NAs, for example. And if I want to do class, even though I just told it to be numeric, you can see for sure that it is numeric. The second way of doing it is with type.convert, and I'm actually going to make a separate data set for this one and call it example base R, because it's going to get messy actually. So right away. So, and the reason why, the fix for it is shown below, which I'm slightly hiding now. All right, let's do it. So X base R is going to be, I'm going to do type.convert. So what type.convert is going to do is it's going to look at, again, it's going to look at this where all the values are character, and it's going to try to convert it to the type it should be. So it's basically kind of reading it in again, and assigning these, whether it's character or not. So all you have to do is do the function and the data frame that you're trying to do. So it's pretty nice because we have both data frames here, character and and this real, where we want this one to be logical and we want this one to be in numeric. And let's print out this value. And what you see here is that it did it. It did the double precision real number, so DBL is actually still numeric, good. LGL, logical, good. But what you can see here is it introduced factors here. And why did it do it? They were characters, and they were happy being characters. And you might be like, oh, well, actually that seems like a good thing, because we wanted characters here. But if we wanted to, I can show you that if we do base R and we sort it again, which is a way to show what order the values are in, and do place, it did it numerically, because that's the default for a factor. So it didn't really help. And then you can see how that might be not problematic necessarily, but kind of weird for the first name here, where there's no reason for them to be in alphabetical order. There's that doesn't have meaning actually for these names. So maybe it wasn't the best thing to do that. So how do we, so this would be EX base R place. So, because that was the one that was type converted, I used base R, but it'll give you the same thing. And it actually prints out the levels here. Whew, glad I caught that. Anyway, so you can see that it's still in alphabetical order because that's the default for factors. Well, the reason for that is kind of that historic reason about strings being converted, or characters being automatically converted to factors. And I have that sort of information here. So you can do stringsAsFactors is equal to false. So that is this argument that was used, I think it was updated last in like 1998 or something like that, when they just changed the name of it. But again, it was talking about when things were a lot more efficient to store, and you had to worry about efficiency when you were using data sets. So the default was actually that stringsAsFactors was equal to true. Type.convert is back from that day, and so the default actually is true. But if I wanted to type.convert for base R, which again, the reason why, if I type.convert for EX base R, since it was factors already, it wouldn't update that. It's like, oh yeah, these are fine as factors. But so I'm type converting this one back here where everything was characters again. And now if I print out base R, you can see. All right, my apologies there. I actually had the argument wrong. It looks like it should be as is equal to true. And then if you run it and then print out the base R, you can see that the ones that were numeric actually became numeric and logical, but it didn't convert to factors. My apologies about that. It actually worked when I was in this practice script I wrote up, where I wrote it right here, and it worked perfectly, wonderfully fine. But we will soldier on. As is another function when I looked into the help about how to convert it, where it converts a character factor unless as is equal to true. There. So, but stringsAsFactors is an argument for a lot of read.csv, a lot of base R functions, and actually not even that long ago, the stringsAsFactors thing would always be set to true. So whenever you write in a table, it would always automatically default to true. Even since I've been studying, they introduced this default.stringsAsFactors thing. So sort of value, and so you can actually set the default stringsAsFactors. So if you are going to use base R and you'd rather have things be factors, or if you'd rather have things be characters, which is usually typically better, you can see that my default is actually set to false. So when I said read CSV, that's why it didn't automatically update it. Maybe if you were running an older version of R, actually, you might actually see that the stringsAsFactors is automatically set to true, and so if you were to try to run this script, it would actually try to send it to be factors right from the get-go, and you wouldn't actually get that, that it was a character ever, and you'd want to potentially convert it back or change the factors at least. So that is just a note about default behavior, and also if you ever see older functions where they say stringsAsFactors is equal to like false, that is because if you run into scripts from like older scripts from publications or what have you, they might have this type of functionality in there, and the reason why is because they don't want the values to be read in as factors, and before that was something you needed to specify when you used base R read. Something though that before we get to the Tidyverse and how they deal with factors and reading it in, to finish off the example, we actually still have a problem with that plot. If I base R looks like this. Again, it's characters here and it's numeric values in the earnings, but it's still going to go through 8th through 3rd because it ggplot automatically assigns values into as factors. So we need to convert it. So here I have a place for where I can convert place to a factor. So we can do that with using the same thing we've been doing before. I want to take the place vector and I want to replace it with a factor where it goes over and rewrites base, place, and the levels are going to be equal to, well, actually they're ordered already, and so I can actually just do base, place. But I wanted to, since they were in an order already, I can actually just have the order be the order they're in. Factor x is equal to that. The levels are already in that order. So again, I didn't type out the full name of the thing. So now I hit enter, and let's just plot it again. And now you see that it's actually descending down nicely, earnings, place, and we have it ordered properly. So if you're putting it all together, I needed to read in the value, I needed to change place because the column name was weird, so I reset the column name. I only wanted to change the first one, so I'm changing the first value there, as in putting it as place. Base R earnings, I want to sub out the $sign and the comma. Let me run this while I talk about it. I'll type convert stringsAsFactors equal to false. It doesn't really matter if it worked or not, if it is factors or not, because I replaced the factors for base R place, the one I'm interested in, with this ordered of factors. So then I type convert it, I introduce place as a factor, I plot it, I get the plot. So that's how you would take care of that in a normal situation. After, exploring maybe a little bit, getting a little bit frustrated, what have you. But now let's talk about the Tidyverse way of handling things. And there are Tidyverse ways to manipulate data as well, but they're pretty different from base R. But there's also some useful functions in the Tidyverse to deal with factors, and among other things that you might want to use even if you're going to use base R functions for most other things. So the first thing we need to do is to use library to call the Tidyverse, and I'm also going to use reader to read in the book 1 CSV as a tidy example. So of course we already read it in, but it's going to look a little bit different actually from the base R example that we used here. Library, it's taking a little bit, but of course read R is in the Tidyverse, so this simply would work. I just wanted to point out that we're using the reader function in particular. You can kind of see Tidyverse usually has an underscore in it. So we can see this, but if you actually look at the names here, notice that there's a space here, and not a dot from before. If you go back to the base R, there was a dot, and the real dot was real question mark actually. So it was actually a question basically. Are these people real? True or false? So you can see though that basically any how the base R functions actually work, and I actually kind of prefer that sometimes, is that they will replace any characters that really shouldn't be in like a space or a dot or like a question mark. They will replace those values as just dots, because those are values that can be easily in the sort of column names of this. And the reason for that is because if you know in base R, you let me just maybe show you a quick example. So if I wanted this tidy example, if I wanted the column that is last name, for example, if I put in last, you can notice the problem that I'm going to have. There's no column that's in last, and then I put a space there, so it's going to stop evaluating it there. So if I run this, I'm just going to get an error because it's an unexpected symbol. There's a space there. So how you can do this, though, is R will allow you to put these, it's the accent mark, it's not a single apostrophe. It's particularly the accent mark in my keyboard that's above the tab key. It's also the key that you can use to use the tilde if you do shift and then that key. So use that accent mark, and now if I do it, it actually lists out those things. But so you can evaluate things that way, but that is the reason why sort of base R, the general format is to replace those values. So renaming this column could be useful if I don't want to put these tick marks every time, but thankfully RStudio is kind of smart about it, and you'll see that in a second. So because actually, well, let me show you. If I do this and I tab, you can see I can sort of tab to complete what it could be, and if I hit first name, it automatically puts it in the accent marks so that it's going to be evaluated correctly. Alright, so like I said, I might want to rename the columns, but for this example I'm not going to do it. So the first thing is going to be parsing. So this is another read R functions, and you can actually get through, remember there was that $sign and the commas and everything? Well, if you just have values and you just want to get rid of the extra symbols around it, you can use this readr function parse number. So since we're using the Tidyverse and we loaded that in, I can use pipes now, which I do prefer to use. So tidy example is going to be pipe to mutate. Mutate, for those who don't know, and we're going to go over this in how to change up data frames this week if you're going to follow the Tidyverse examples. Mutate is very similar to assigning a column. So like in base R you would do this and you would kind of rename first name or you do something with it. Mutate is going to, or if you wanted a new column, you could just do new column and assign it to be, you know, whatever values you want it to be. Mutate works the exact same way, except is like the equivalent of that in the Tidyverse. So mutate, you're taking earnings, so that is going to be the name of the column. We already have a column named earnings, so it's going to replace it, just like how it would do if you had the $sign earnings. We're going to replace it with what we're going to, and then here you use equal sign. You're going to replace it with parse, the output of this function parse number, and let's just see how it works. And you can see here that it takes that $sign and the comma values that were there before and replaces them, and just has the number. So really convenient way of doing that. So again, there's a lot of useful functions in the Tidyverse, in readr, for example, and on all the Tidyverse packages, but you have to kind of know that they're there. So for example, this one I had to actually just Google how you do this again. So whether it was fast or not is kind of a thing. So alright, so the next, I wanted to show you some things that won't work. So for the example, could I just do the same thing with real question mark, and could I, here it is again, can I just parse that as logical, because it worked really well for earnings? Would it work for this? And the answer is no, it doesn't, because it actually just gets rid of that value, and it says it's an A. And now, like, well, can I just replace that first value like how I've done before in baseR with mutate? And the answer is also no. So this is kind of an important thing to note about how, well, if you notice what happened here, it gave you something, but it's not what you want. It's giving everything true here. It changed everything. And you can see it actually put the column, it basically has this as the whole column. You can even try with an equal sign, and it's not going to work either, because it doesn't know how to do with deal with the equal sign. So the reason for this is because mutate and tidyverse functions, how they're designed to work is to function on the entire column. They always work on the entire column at a time. So you're manipulating the whole thing. The idea of this is because you want to manipulate the whole thing typically. Like, right, you want to do something, you want to log transform all the numbers in that column, so that they want that to be the default value. So that's why you have to be a little bit careful with the Tidyverse. There are ways to do, just like, let's say you wanted to change, you know, certain values. You can do things where you use mutate real, and let's say, so I could actually do it this way. It's going to be equal to if else. It's a function from dplyr. You set a condition, what happens when it's true, and then what happens when it's false. So the condition could be is.na. The value when true is going to be, well, I know that the only na value happened to be true, and the false, we want actually just to take the values originally from the real, right? So for this one, just take the values that were originally in real. If it's na, though, replace it with a true, is how you read this. So, sorry, I forgot to put real question mark is in the na because I didn't actually do the test. And you can see what it did here. Replace that one na value with a true, and then left everything else alone. So you can do it with if else. If else is a very useful thing to use in dplyr with dplyr functions. There's also the base function if else, which is pretty much the same thing, a test, yes or no. Slightly different arguments that you have to parse through, but I'll let you look into that. And it kind of gets us into thinking about how you write if statements, which will be something we cover out later. So a couple of useful things to give you an example of. So again, you could manipulate it just by itself, but most of the time you're going to manipulate the entire column, and that's why, and that's why you'd want to do that. So how could we do it if we wanted to just remove the strings and type convert and asFactors? So we're going to do the same thing that we did before in baseR, but doing it in the Tidyverse. So let's get tidy example, and you notice here I always piped, so I never rewrote tidy example. So although I printed these columns out, or this table out every time, the table doesn't actually exist. I didn't ever rewrite it. So that's why if I just, let's just print it out to see how it looks like again. See what we're working with. You can see that they're all characters and they're all true. So let's remove the strings. So I want the first thing to do is to mutate earnings, and I'm going to replace the earnings with, well, earnings, and there's actually a stringer package that's also part of baseR. So instead of doing gsub, I can do one of the stringer replacements. So I can say stringer replace all, which is the same, essentially the equivalent of gsub. There's no difference. It's going to be replace would replace just the first one, this one is going to replace all of the patterns. So in this case, you give the string first. I actually think that the Tidyverse packages are ordered in a way that I think of it a little bit better. So earnings, and then the pattern is going to be $, or comma. Again, we can use that again. And the replacement is going to be nothing. So that works for me. And for this true values, this real, there's what I'm actually looking for. If I want to take it a different approach, like I could replace it with an if-else, something like that. But really what I want to do is get rid of any time there's a quote mark, right? Like that would work for all of, if there was quote marks around all of them. And we can do that as well. So in this case, I'm going to do real and tab complete it, so it puts in the accent marks. I'll notice also that I could write another mutate line, so you can write it as multiple different ways. You can put a comma and you enter it in, and this is actually going to do another column, and it's going to create another column. In this case, it's just going to rewrite real. This would just kind of save a little bit from actually closing it, doing another pipe and saying real. Those would be equivalent if I left it with a comma, but sometimes it's a little bit easier to see this way. Sometimes it's just convenient to write multiple mutates in one under one function. So let's put real and let's do str, and this time I'm gonna show you that there's actually a nicer one. There's actually a remove pattern, and you can see it's an alias for replace string pattern quote. So I'm gonna remove all. If I just removed again, it would only remove the first instance of it, and since there's actually 2 quote marks, that wouldn't work this time. So this string is going to be real again, and let's put the pattern as, so this time I'm going to use a quote mark, and you can see that it's going to get confusing if I use quote, quote, and I'm going to try to put another quote, and you see that this becomes green. This like after part's green, and there's going to get an error there. This isn't, well, that says an unmatched bracket, but that's because it's thinking these are characters now. And so that this, for example, is unmatched. So how can you actually use quote as a character, like give the character quote? Well, there's actually 2 ways to do, to say it's a character or string. You can use the, quote, or you can also use the sort of apostrophe. So, I can actually do this, and now it knows that the apostrophes are together, and the inside of this is the quote. So it's going to replace that. And, I can't actually remember if I have to escape it or not, so we'll find out. Nope, you don't have to escape the quote mark. And you can see that it replaced it with nothing, and you have this. So now these look fine, but I need to change it. So let's do a type convert, and also there's a type convert. This is the utils one, or you can use the reader function, which is slightly nicer because it's actually never going to convert it to strings because it's a Tidyverse function, and Tidyverse reader never, the default is always to leave it as character. So, and now you can see that it's a double precision real. It's logical characters all around. We're almost there to where we want it to be. The last thing is going to be just to take it and move it as a place and put it as a factor. So this one we're going to also have to mutate, and we're going to mutate place to be equal to, well, and there's this function also in the Tidyverse that is Forecats. And if you're wondering why it's called Forecats, it is an anagram of factors, and I realized that today. So the first function here is asFactor. Again, it's already part of the Tidyverse, I just wanted to call out the name of the library if you want to just use the library, and AsFactor. And AsFactor does the thing that you want it to do. It actually takes, if it is in the correct order already, it will just use that order to assign factors. So I don't have to put factors and then say it again. It's not that difficult. I could just say factor, place, and it would work, but you know, I'm just that lazy. So AsFactors, and you can see it's a factor. You know, let's just assign this to be something. So I would also recommend, if I could continue to do this and pipe into ggplot to check to make sure that, you know, and do the final plotting and everything, but I would highly recommend that you keep your data and the plot separate, just because it's a little bit nicer. Just from my experience, it's nicer to have the data separate from the plot, at least in the final version, so you can make changes a little bit nicer to the data or the plot, and not have to worry about everything. So in this case, if I want, I can do plot tidy and pipe that into ggplot, and it's going to take on the first function. So that's how the pipes work. If I haven't explained that already, it always goes and defaults to the first thing. So plot tidy goes and puts it into the data, and that's actually why the Tidyverse works so well with pipes, is because the Tidyverse, the first thing in mutate actually is data. What data are you going to mutate first? And so that's why it works really well with piping in this. If you ever need to specify, it should work if you do data is equal to dot. The dot is actually going to be interpreted as the thing that you're piping it into. So, and then we use a plus for ggplot. I usually like to tab over for all the plot is like that. Call. I forgot to do the mapping, so I'm going to do it now. X is equal to the place. I remember the variable name, and Y is equal to earnings. So now, if I plot this, it should plot the way that I wanted it to do before. So basically, this is the tidy example of how you could do that. Again, you could actually do it a little bit easier by using parse number instead of the string replace all, or string remove all. I didn't actually mention this. I did want to say the one reason I wanted to use replace here is because typically this like shorthand of doing a replacement with nothing in it or using nothing comes up if you want to paste something together but not have anything actually separating it. You can use paste, and then the sep is equal to, you know, this. It's just the quote marks. So it comes up, and there are functions that often will sort of simplify that for you, so you don't have to type replacement is equal to this or anything like that. But, you know, again, just kind of going back to, there isn't a base R equivalent to str remove all. You could probably find another package that does it, but that seems not worthwhile to load a package just to do that. So finally, I wanted to go and mention one more thing about the Forecats package. I've really been using this slightly for a couple of years, and I only realized it today that that's anagram for. I was really confused at why. I thought they just like cats or something. Anyway, the forefathers. Now I'm thinking of like Forecats as in forefathers. I might edit that up. Anyway, so let's go. So let's order things in a different way. So I'm gonna go back to tidy example. So the first thing I'm gonna do is to take the earnings again and just replace it and make it numeric. I'll use the parse number function this time. And again with dplyr, I should have mentioned this earlier, but again, with the pipes and everything, the reason why you don't need to note, like do a dollar sign type of thing, is because it assumes that it basically takes and it kind of stores the values that you're using, place, earnings, first name, last name, real, and everything, and it's going to store that as a vector that it kind of knows, and that's why you can actually autofill it when it's a tibble that way. So that's actually, pretty convenient notation as well, so you don't always have to do like write out the full name of the example you're using, or the data frame you're using, and then a dollar sign. That's just, you noticed that probably in ggplot already, where you can specify just earnings or just the x or y values without saying what data frame they're coming from, because you specify the data already. So mutate that, and I have earnings. And now I want, let's say that these were sort of in a random order, but they were still corresponding, right? So like maybe it was in alphabetical order. And actually, maybe we can do that. We want to, arrange the function, which is another dplyr function, so kind of getting more into data wrangling with dplyr. We want to arrange by place, and again, it's going to do it alphabetically because that is the default, and you can see that everything kind of got mixed around. So if I had the data frame like this, how would I sort it so that do the factoring, because it would be a little annoying to write the levels out again. Not that annoying because there's only 8 factors, but maybe if I had a graph with larger things or where it was unclear. And I just wanted the graph to look like this, right, where it steps down or maybe steps up. I'm getting towards it. Factor reorder is going to be your friend here. So I'm going to mutate again. I'm going to mutate place to be a factor, and in this case, but instead of using AsFactor, because it would be just, it would actually go in alphabetical order, it would go in the order that it's presented there. I'm going to use this factor reorder, and I'm going to reorder place is going to be the place with the first argument, and the second argument is what I'm ordering it by. And in this case, I'm going to order it by earnings. You know what? Let's just pipe it into ggplot, just so I can have the example. Column, and again, make x is equal to place and y is equal to earnings. If I set that all up, you'll see that it went 8th to 1st. So what it did, now it didn't go because the 8th was, the first thing in alphabetical order or anything. It went because in this order, because it went by what values the earnings was in. So it looked basically at what the lowest value of earnings was, and it assigned it to be the first ordered so that it steps up. If I wanted to redo this, there's this .desc, and sometimes it's just, there's a very common thing if you're sorting something just to do desc is equal to. In FCT, it's .desc for not a reason that needs to be explained.
Good night, Robert.
Good night. And I set that descending in is equal to true. Usually it's equal to false. And if I plot it this way, now the factor is going to be ordered so that it goes from highest to lowest. And so you can see that first is actually going to be first, and it's going to step down like this. So it's a really convenient way to assign a factor based on the values of something else. So it assigned the factor based on the order, the values of an earning. You can also do it by infrequency, so sort it by how frequent it appears in the data set. So again, this could be useful if you just want to make graphs slightly prettier by having it scale down and the order doesn't really matter, and that's going to help just make it how you want to look. I don't have a good example for using infreq in this data set. Maybe if I use the same name a couple of times and I wanted to see, what first name was, the most represented. But there's actually this Star Wars data set, and it has the Star Wars characters by eye color. And this is the example that FCT infreq uses, not me. So I just copied and pasted it from online. It loads the Star Wars dataset and it puts eye color, and it's by the frequency. Again, it actually does it from sort of low to high, and if the value does repeat, you can see that it is actually in alphabetical order. In this case, it's descending is equal to false, so that's why it's going from starting at the end of the alphabet, white, and marking its way back to blue. White is not the end of the alphabet, but it's in this list. It is the the lowest value, and you can see what they did here, just to graph these bars by counts in this way. So that's all. That's all for this video. It's quite a lot, but hopefully you found some of these random details and asides kind of interesting, and how to work with factors to make it so that you can plot them in the order that you want, which probably would have been helpful even starting with homework 02, but also going over and how to just like manipulate data when it's slightly annoying. Alright, I'll see you guys in the next video. Take care.